This is a bag of seaweed. It is being held up and is motionless with the tension from a string and by gravity.
There are two forces, one for the force of tension that is holding up the seaweed and one for the force of gravity. Since there are only in the y direction, there are no x forces. There are only ones in the y direction. So ft, and you don't know that one. And the force of gravity is the mass of the seaweed times the acceleration. And the seaweed weighs 0.005 kilograms times the first acceleration, which is negative 9.81, which would also mean it is negative 0.049 newtons. So to find the force of tension, we have to find the net force in the y direction. And then half them equals 0. And then we just subtract it to the other side, and then the force of tension will equal 0.049 or positive 0.049 newtons. And then these are the values of the forces.
This is another seaweed package moving on at a 30-degree angle down a music stand with friction going against it.
So for the second example, there was seaweed sliding down a music stand at a constant velocity with friction acting on it, and the music stand at a 30-degree angle with normal force and the force of gravity, which all balance out. So just move everything down by 30 degrees. And then for here we don't know the force, the kinetic friction, or the normal force, but since from the last one we know that force of gravity with the mass times the acceleration of the Earth is 0.049 newtons, and find the x part of it, you multiply 0.049 times the cosine of the standard angle of 300 and you get 0.245 newtons. You do the same except with the y direction, and you multiply 0.049 times the standard angle of 300 times the side. You get negative 0.04, it should be 0.245.0424 newtons. And then you find the net force in the x direction, which is the friction plus the force of gravity in the x direction, which is 0.0245, and then you set it to equal 0 n, and then you subtract the force of gravity from this side to that side, and you get the kinetic friction equals negative 0.0245 newtons. You do the same except in the y direction with the normal force plus the force of gravity in the y direction, which gives you, and set it to 0, and which gives you Fn plus negative 0.0424. You solve it, and the normal force equals 0.0424 newtons.
Yay! This seaweed package has 4 forces acting on it. One for normal force, the force of gravity, applied force, and kinetic friction. And that was gravity.
Okay?
Mhm.
Is it?
Mhm.
So the third example has 4 forces on it. One is normal force, the force of gravity, and then the applied force and the kinetic friction on it. I'm not exactly sure how many newtons were applied, so I just said it was 3 newtons. So for the x direction, we know that the applied force was equivalent to -3 newtons, but we don't know the kinetic friction. And then for y, we don't know the normal force, but from the previous videos, we know that the force of gravity is the mass times the acceleration, which is -0.049 newtons for the force of gravity on the seaweed. And then when you combine 2 forces in the y direction, you get the F net. The F net is the normal force plus the force of gravity. And when you set them to equal 0, it's Fn plus -0.049 newtons. And then you add the force of gravity to both sides, and you get 0.049 newtons for the normal force. But in the x direction, you add the applied force and the kinetic friction. And you set them to equal 0. And since the applied force is equal to -3 plus kinetic friction, you add it to both sides, and the kinetic friction equals 3 newtons. Yay!
Don't want to break him.
It's alright, just.
He has to march in Chinatown.
It's okay.
No, he doesn't.
I said one of his
Oh, feet! It's gonna hurt me. These Vans, I bought these in China.
You know that. Where are they going in? Oh, why did you leave me there?
No, just go here. The back.
Go behind. No, go behind me.
Is your foot numb yet?
I'm not flying all there.
Okay.
This hurts really bad.
I'm so excited. Yay!
All for science!
This is bull.
Paying for science. Okay, let's get off it.
Okay.
Let's get off it.
For a second there, my foot forgot what blood was.
For the last example, there are 5 forces. There's the force of gravity from Jalex, and then the force of gravity, or the applied forces from the 3 other people, and then all of that is with the final force of the normal force. It's all in the y direction. There is nothing in the x direction, but for y, we have to find out how many newtons everybody weighed. So for the gravity, you have Jalex with his weight times 4.45 newtons, and then you get 623 newtons. And then we followed suit with everybody else's weight times 4.45. And then to find the net force of all of them, you add the force of gravity and the 3 applied forces and the normal force. You set that all to equal 0, and then you add all of 2 numbers, which is -6.23 plus -734.25 plus -556.25 plus -578.5 plus the normal force, which would equal to -2492 plus the normal force, and which would make the normal force 2,492 newtons. Yay!